I want to take a look at the product rule and the quotient rule now that we have the notion of logarithmic differentiation. I mean, I know how to take the derivative of a product. It's the first times derivative of the second plus the second times derivative of the first. But let me do this in terms of logarithmic differentiation and see how it ties together with a bunch of other things here. Take the natural log of both sides. So I got the natural log of y over here is the natural log of f of x times g of x. Well, this breaks up into the natural log of f of x times the plus the natural log of g of x, because the log of a product is the sum of the logs. So I've got log y equals this. Now I implicitly differentiate. So the derivative of the natural log of y is the derivative of all this stuff. ln f of x plus ln g of x. Okay. Derivative of natural log of y with respect to x is 1 over y times dy dx equals the derivative of the sum now is the sum of the derivative, so derivative of log of f of x would be 1 over f of x times the derivative of f of x. The derivative of natural log of g is 1 over g of x times the derivative of g of x. Okay. So you got the derivatives on the top and the functions on the bottom. Solving for y, dy dx now, solving for dy dx, multiply both sides by y here. I've got y times this stuff, f prime of x over f of x, plus g prime of x over g of x. Y now is f of x times g of x. And I'm going to multiply it by this thing here. And watch what happens. We've got a distributive property. I've got to take this stuff and multiply it by the first thing. I've got to multiply it by the second thing. Well, when I multiply f times g times this fraction here, the f's cancel out. And I get g of x times f prime of x. When I multiply this times the second fraction, the g's cancel out, leaving an f of x times g prime of x. And all of a sudden, I've got what looks like the product rule. First times the derivative of the second, plus the second times the derivative of the first. Now it's written in a different order, but addition is commutative, so that's okay. All I used was a property of logs to break products into sums, implicit differentiation, and the derivative of log functions. How do you take the derivative of log of something, right? And then you get it back, and you've got the quotient rule. Sorry, the product rule. Let's do the quotient rule now. Let's start all over again here. Let's say y equals f of x divided by g of x, right? And I'm not going to use the quotient rule here. I'm going to use logarithmic differentiation to see if I can find the derivative. So the natural log of y is the natural log of f of x divided by g of x. Just take the natural log of both sides. Now use the property of natural log on this side here to break that up. Natural log of y is the natural log of f of x minus the natural log of g of x. It's a quotient now, so it's a difference of those two logs. Implicitly differentiate on the, all right, we'll write it down here. Derivative of natural log y with respect to x equals the derivative of all this stuff, natural log f of x minus natural log g of x. With respect to x. And, okay, take it now. So the derivative of natural log of x, the natural log of y would be 1 over y times the derivative of y. And over here, the derivative of a difference is the difference of the derivatives. So the derivative of the natural log of f of x, the f of x goes in the bottom, and f prime of x goes on top. The derivative of the g of x now, the g of x goes in the bottom, and the g prime of x goes on top. Solving for dy dx, multiply both sides by y. So f prime of x over f of x minus g prime of x over g of x. And y, what was y? Y was the quotient of f and g, so let's plug that back in here. So I've got f of x divided by g of x times all this stuff. And now I'm going to use a distributive property and multiply this fraction times both of those. And what happens when you multiply it times this first one, the f's cancel out, and I've got f prime of x divided by g of x. And then this times the second fraction, nothing cancels out. You've got f of x times g prime of x divided by g squared of x. And then I'm almost home. Get a common denominator, multiply top and bottom here by g. So this becomes g of x times f prime of x minus f of x times g prime of x. And you'll have a denominator here now of g squared. So that's g squared x. And there is the quotient rule. Right? Logarithmic differentiation. Where do we start? Right here. Logarithmic differentiation. You take the log of both sides, use the properties of logs to split this up now, and that quotient turns into a difference, hence the minus sign that went carried all the way through. Right? Take the derivative of both sides, use the properties of the derivative of the log here, and solve for dy. That's a dx dx. Why does it say dx dx? It should say dy dx. Sorry, that is dy dx is equal to all this. And we get the quotient rule out of this. Okay? We got the product rule to start with, we get the quotient rule to finish. It should work that way because all this stuff works together. Okay? There you go.